Chemistry, Section 1, Physical Chemistry. Structure, postulate of quantum mechanics, operators, time dependent and time independent Schrödinger equations, Born interpretations, direct bracket notation, particle in a box, infinite and finite square wells, concept of tunnel, particle in a 1D and 2D and 3D box, particle in a box में finite or infinite square well, concept of tunneling, particle 1D, 2D और 3D box में है. Applications: harmonic oscillator, harmonic and unharmonic potential, Hermite polynomial, rotational motion, angular momentum operator, rigid rotor, hydrogen and hydrogen-like atoms, atomic orbital, radial distribution function, multi-electron atom orbital approximation, electron spin, Pauli exclusion principle, Slater determinants, approximation method, variation method, and secular determinant, first order perturbation techniques, atomic units, molecular structure, and chemical bonding, Born Oppenheimer approximation, valency bond theory, and linear combination of atomic orbital, molecular orbital, LCAO, molecular orbital theory, hybrid orbitals, application of LCAO, MO theory to H2 plus H2, orbital theory MOT of homo and heteronuclear diatomic molecule, Hooker approximation and its application to annular pi electron system, group theory, symmetry element and operation, point groups and character tables, internal coordinates and vibrational modes, symmetry adapted linear combination of atomic orbital, LCAO-MO, construction of hybrid orbital using symmetric aspect spectroscopy, atomic spectroscopy, Russell-Sounder coupling, term symbol and spectral detail, origin of selection rule, rotational vibrational electronic and Raman spectroscopy of diatomic and polyatomic molecule, line broadening Einstein coefficient relationship of transition moment integral with molar extensions, coefficient of oscillator strength, basic principle of nuclear magnetic resonance, gyromagnetic ratio, chemical shift, nuclear coupling, equilibrium, law of thermodynamics, standard states, thermochemistry, thermodynamic function, and the relationship, Gibbs Helmholtz and Maxwell reaction, Gibbs Duhem equation, Van Hoff equation, criteria of spontaneity and equilibrium, absolute entropy, partial molar quantity, thermodynamics of mixing, chemical potential, fugacity activity and activity coefficient, ideal and non-ideal solution, Rolle's law, Henry law, chemical equilibria, dependency of equilibrium constant on temperature and pressure, ionic mobility and conductivity, Debye-Hückel limiting law, Debye-Hückel and Sager equation, standard electrode potential and electrochemical series, electrochemical cells, Nernst equation and its application, relationship between electrode potential and thermodynamic quantity, potentiometric and conductometric titration phase rule, Clausius-Clapeyron's equation, phase diagram of one component system, carbon dioxide to water, sulfur, two component system, liquid vapor, liquid liquid, solid liquid system, fractional distillation, azeotropes and euthetic, statistical thermodynamics, microcanonical, canonical and grand canonical ensemble, Boltzmann distribution, partition function, and thermodynamics property. Kinetics topics has been rearranged. Elementary, parallel, opposing, and consecutive reaction, steady state approximation, mechanism of complex reactions. Unimolecular reaction, potential energy surface, and classical trajectory concept of saddle points, transition state theory, Eyring equation, thermodynamic aspects, Kinetopolymerization, catalyst concept and enzyme catalyst. Kinetics, isotope effects, fast reactions. Kinetics, relaxations, and flow methods. Diffusion control reaction, kinetics of photochemical and photophysical process. Surface and interface, physis options and chemis options. Langmuir, Friedrich, and Bernard, Emmett, Taylor, BET isotherm. Surface catalysis, Langmuir, Hinchell, Wood. Mechanism, surface tension, viscosity, self-assembly, physical chemistry of colloids, missiles and macromolecules. Inorganic chemistry, main group element, hydrides, halides, oxide, oxoacids, nitrides, sulfides, shapes and reactivity, structure and bonding of boron, carborane, silicon, silicate, boron, nitride, borosine and phosphozine. Allotrope of carbon, phosphorus and sulfur, industrial synthesis of compound of main group element, chemistry of noble gases, pseudohalogens and interhalogen compound, acid base concept and principle Lewis Bronsted HSAB and acid base catalysis. Transition element, coordination chemistry structure and isomerism, theory of bonding, VBT, CFT, MOT, energy level diagram in various crystal field. CFSE, application of CFT, Jahan Teller distortion electronic spectra of transition metal complex. Spectroscopic terms, symbols, selection rules, organ, Tanabe-Sugano diagram, nephrostatic effects, and rational parameter. Charge transfer spectrum, magnetic property of transition metal complex, rate depth, and violet west. Reaction mechanisms, kinetic and thermodynamic stability, substitution, redox reaction, metal-metal multiple bonds. Lanthanide actinide recovery, periodic properties, spectra, and magnetic property. Organometallics, 18 electron rule, metal alkyl, metal carbon, and metal olefins. A metal carbene complex and metallocene. Fluxionality in organometallic complex, types of organometallic reaction, homogeneous catalysis, hydrogenation, hydroformylation, acetic acids, synthesis, metathesis, and olefin oxidation, heterogeneous catalysis, Fischer-Tropsch reaction, Ziegler-Natta catalyst, polymerization, radioactivity, detection of radioactivity, decay process, half-life of radioactive element, fission and fusion process, bioinorganic chemistry, iron Na plus K plus transport, oxygen binding, transfer and utilization, electron transfer reactions, nitrogen fixation, metal enzyme containing magnesium, molybdenum, iron, cobalt, copper, zinc, solid crystal system, lattice, Miller planes, crystal packing, crystal defect, Bragg's law, ionic crystal structure of AX2, ABX3 type compound, spinor band theory, metal and semiconductor, instrumental method of analysis, UV visible fluorescence and FTIR spectrophotometry, NMR and ESR for spectroscopy, mass spectrometry, atomic absorption spectroscopy, Mozambique spectroscopy, iron and astatine and X-ray crystallography, chromatography including GC and HPLC, electroanalytical method, polarography, cyclic voltammetry, ion selective electrode thermoanalytical method. Organic chemistry, stereochemistry, chirality and symmetry of organic molecule with or without chiral center and determination of their absolute configuration. Relative stereochemistry in compounds having more than one stereogenic center. Homotopy, enantiotopics, stereotopic atoms. Group phases, stereoselector and stereospecific synthesis. Conformational analysis of acyclic and cyclic compound. Geometric isomerism and optical isomerism. Configurationals and conformational effect. Earth isomerism and neighboring group participation, reactivity, and selectivity or specificity. Reaction mechanism. Basic mechanistic concept kinetic versus thermodynamics control. Hammond postulate and Curtin-Hammett principle. Method of determining reactions. Mechanism through kinetics, identification of product, intermediate, and isotopic labeling. Linear free energy relationship, Hammett-Taft equation. Nucleophilic and electrophilic substitution reaction, both aromatic and aliphatic. Addition reaction to carbon-carbon and carbon heteroatoms, nitrogen and oxygen multiple bond. Elimination reactions. React to intermediate carbocation, carboanion, carbene, nitrine, arene, and free radical molecular rearrangement. Organic synthesis. Synthesis reaction mechanisms and selectivity involving the following classes of compounds: alkene, alkyne, arenes, alcohol, phenol, aldehyde, ketones, carboxylic acid, ester, nitrile, halide, nitrocompounds, amides. Use of magnesium, lithium, copper, boron, zinc, phosphor, sulfur, astatine, and silicon based reagent in organic synthesis. Carbon-carbon bond formation through coupling reaction. Higgs, Suzuki, Stille, Sonogo, Negishi, Kumara, Yama, Tsuji, Trost, Olivier metathesis and McMurray. Concept of multi-step synthesis. Retrosynthetic analysis, strategic disconnection, synton, and synthetic equivalent. Atom economy and green chemistry, Pumpolong reactivity, formal and acyl anion. Equivalent selectivity in organic synthesis, chemoregio and stereoselectivity, protection and deprotection of functional group concepts, asymmetric synthesis, resolution including enzymatic desymmetrization and use of chiral auxiliary organocatalysis, carbon-carbon and carbon heteroatom bond forming reaction through enolate, including boron enolates, enamine and silyl enol, they ether, stereoselectivity and additions to carboxyl groups, CRAM, Prelox, and Felkin and Haar models, pericyclic reaction and photochemistry, electrocyclic, cycloaddition and sigmatropic reaction, orbital correlation, FMO and PMO treatments, Woodward-Hoffmann rules, photochemistry of alkene, arenes, and carbonyl compound, photooxidation, photoreduction, di-pi-methane rearrangement, Barton-McCombie reaction, Norris type 1 and type 2 cleavage reactions, heterocyclic compound, structure, preparation, properties, and reaction of furan, pyrrole, thiophene, pyridine, indoquinoline, and isoquinoline. Biomolecule structure, property, and reaction of mono and disaccharide, physiochemical property of amino acids, chemical synthesis of peptides, chemical structure, determination of peptides and proteins, structural feature of protein, nucleic acid, lipids, steroids, terpenoids, carotenoids, and alkaloids. Experimental technique in organic chemistry, optical rotation, polarimetry, application of various photographic techniques such as thin layer, column, HPLC, application of ultraviolet visible IR, NMR, and mass spectrometry in the structure determination of organic molecule.